This video is sponsored by His Vessel Academy.
How many of you are struggling with that word division of polynomials? So we're going to today talk about synthetic division. And this is actually an easy way of turning a hard problem into a manageable one. The first thing I want to do is I want to set x minus 1 equal to 0. So whatever's over here, I want to set it to 0. And I want to add 1 to both sides. So I want to make sure that I have x equals 1. Okay? And that's the number I'm going to use for division. So we're going to go ahead and try this. All right. And it's a pretty simple one. It's not too bad. The first thing I want to realize is I do have 4, 3, 2, 1, 0. Okay? I want to make sure all of my x's are there. I have a positive 16, so I'm going to write it 16 here. I have a negative 32. I'm going to give myself some room. I have a negative 13, a positive 28, or 9, sorry, and a negative 6. So we're going to extend that a little bit, and I'll erase that in a second. Okay, so the first thing I do is I take this number right here and I bring it down. So whatever the first number is, whatever the coefficient is, I'm just going to bring it down. And then I take and I multiply this 1 times 16 and then put it right there. So I just do that. And I'm going to continue to do that all the way across. And it's actually not too bad when I do it. So then I go negative 32 plus 16 gives me negative 16. So I'm just going to add these two. I'm going to add whatever I got. And then I do it again. And I go 1 times negative 16 is negative 16. Got it? And then I take negative 13 plus negative 16, because remember I'm still adding, and they are both negative, so I know I'm going to end up with a negative number, but that gives me negative 29. So far so good? I'm going to now take 1 times negative 29, I'm going to put it in here, and positive 29 plus negative 29 is actually plus 0, so I don't have anything there. And then I'm going to go, well, 1 times 0 is 0, so I end up with a negative 6. And this particular fraction is going to have what we call a remainder. Sometimes they do, sometimes they don't. If this had been a positive 6 when I got done, I wouldn't have had a remainder. But I want to show it to you with the remainder. So now that I have this 16, this negative 16, this negative 90 or 29, and this 0, and this negative 6, what do I do with them? So the first thing I want to do is I want to take this 4, I want to see what my highest degree is, and subtract 1. Well, 4 minus 1 is 3. So what I'm going to do here is I'm going to have 16, x cubed, and then I'm going to write the next coefficient, which is negative or minus 16, and then I have x squared, and then I'm going to go negative 29, and I have x. And then I go plus 0, which later on I probably won't write in my equation. You don't need it. But I'm going to show you where it goes in case you have a number there. Now I have a remainder. The remainder actually goes negative 6 over whatever I multiplied it through. So my original division problem, which is, so that would be a plus by the way, or minus in this case, x minus 1. So if I wanted to write this a little bit neater, I would write 16x cubed minus 16x squared minus 29x minus 6 over x minus 1. And that would be my final answer. So I got rid of my 0. I did bring the negative out to the front, so I have a minus instead. Not a big deal. And there's my final answer for that one. The next one I want to show you is when you don't have all your x's. You'll notice here I have 4, but I'm missing 3. I have a 2, a 1, and a 0. Still the same number here, so I'm still going to use 1. I still took x minus 1 equals 0, and I end up with x equals 1. So I'm still going to use a 1, so I'm using a pretty simple number. I'm just trying to show you the procedure, so that made it easier for me. So 16 is my first one. I'm going to write that. I don't have an x cubed, so I have to put a 0 in its place. I still have to count it. I just have to put a 0 there. So now I have a negative 13, a positive 29, and a negative 6. So let's see what happens now. I'm going to write my 16 right here. I'm going to go 1 times 16, which is 16. I'm going to add these two. I end up with 16. And I have 1 times 16, so I still end up with 16. And this gives me a positive 3. Okay? Well, 1 plus 3, or times 3 is 3. And this gives me a 32. And 1 times 32 is just 32. So I'm still going to have a remainder for this one, but you see how I had to put a 0 in here. And if I look at that, that's going to be 26 is my remainder. Okay, so this is my remainder here. Anytime I have a number at the end, it's going to be a remainder. So again, I'm still going to have my 16x cubed plus my 16x squared plus my 3x plus 32. And then it's going to be plus 26 over x minus 1. So when I have a remainder, it does have to go over this right here. So let's try this one. This one, I still have to do my x plus 3 equals 0. I'm going to subtract 3 to both sides. I end up with x equals negative 3. Okay, so I'm going to use that, my negative 3. I'm going to go ahead and write my coefficients. In the 3, I have a 3, 2, 1, 0, so we're good. I don't have to add any zeros in there. I have a 1, I have a 2, I have a negative 5, and a negative 6. Okay, I'm going to bring my 1 down, just like I did before. Negative 3 times 1 is just negative 3. And then I'm going to add these two, which gives me just negative 1. Negative 3 times negative 1 gives me positive 3, because two negatives make a positive. So now I end up with negative 2. And I have negative 3 times negative 2 gives me positive 6. Now I don't have a remainder. Once I get a 0 here, I have no remainder, which means that this here is a factor of this polynomial. The other one wasn't a factor of it because it gave me a remainder. So now I'm going to go ahead and I'm going to take, I'm at a third power, so I know after I subtract 1, I get 2, because 3 minus 1 is 2. So I have 1x squared minus x minus 2, and that's my answer. So if I was to divide x plus 3 into this, my answer would be x squared minus x minus 2. And it kind of, thinking about it, of a polynomial, I'm kind of breaking it down because I want to know where my factors are, where it crosses the x-axis. This is literally what I'm looking at. So if I was to graph this, my polynomial, or my weird, it's kind of a, well, it's a more of a...
This video is sponsored by His Vessel Academy.
An S shape. But it would, my polynomial would cross at negative 3 on my axis. So that's what I have so far. And I can do it again. If I have another, if I can figure out what another one is, and I think the other one is like x minus 2. And I could go again and do it again until it's really tiny, or I could use the quadratic formula. At this point, I could probably use the quadratic formula and just factor it. All right, hopefully that helps with synthetic division. You have a good day, and I'll see you next time. Like this video if you like this, so I can make more of them. And hit the subscribe button so you get all my videos when they come out.
At His Vessel Academy, we offer live interactive classes as well as some self-paced courses. Visit hisvesselacademy.com for more information and register today.